Assalamualaikum and hello to everyone. In today's video lesson for our course MEC351 Refrigeration and Air Conditioning, we will cover Chapter 2 titled Air Psychrometric. So for this video, we will try to cover Subtopic 2.7, the psychrometric chart, where the objective for this subtopic is that students should be able to use the psychrometric chart as a tool to determine the properties of atmospheric air. Okay, now let's look at the subtopic, the psychrometric chart. First of all, students should ask what is a psychrometric chart. So psychrometric chart is basically a tool used in the industry, okay, by air conditioning designers when they want to design air conditioning system. Okay, so when they want to design air conditioning system, the first thing they have to determine is the properties of the atmospheric air at the current location. Okay, so the easiest way to determine the properties of air so that they can design the air conditioning system is by using the psychrometric chart. Okay, they can use equations also, but equation will require calculation and it will take a lot of time. So the easiest way is to use the psychrometric chart. Okay, so basically using the psychrometric chart we can read, okay, we have to plot, okay, the chart, and from plotting the chart we can read the remaining properties. Okay, so there are 7 properties here. If we count the number of properties written in the slide right now, there are 7 properties. Okay, so each property is corresponding to a section in the psychrometric chart. If we look on the right, the psychrometric chart, so there are 7 locations, okay, to where we can read the values for each of this property. Okay, so that is the first objective for a psychrometric chart, is to help air conditioning designers to make reading the properties for atmospheric air easier. Okay, so and the second objective, okay, the use for psychrometric chart is to visualize, okay, is to give a picture, okay, visualize when there is an air conditioning process. Okay, so when they want to design an air conditioning system, if the system involves a process, let's say for example heating process, so we can plot the chart, okay, and we can look at uh, the movement, okay, the perbezaan, okay, from initial to final, what will happen to the properties of air, okay, after undergoing the process. Will the temperature increase, will the specific humidity decrease, will the relative humidity increase? We can see, okay, when we plot the chart we can see what will happen to the air after undergoing a certain type of process. So that is the second objective for a psychrometric chart, is to help visualize what is going to happen if an air conditioning process is involved. Okay, so on the right of the screen right now is the psychrometric chart. Okay, so there are 7 locations, okay, so that we can read the property. Okay, we have the x-axis, okay, is the dry bulb temperature, okay, and then we have the y-axis, okay, is the specific humidity. For specific humidity, the values are 2, 4, 6, 8 up until 30. Okay, so those are the values for specific humidity, and the units for these values are in grams. If we can read properly at the axis there, it is written that the unit for omega here is in grams moisture per kilogram dry air. Okay, but remember, unit for omega is in kilograms vapor over kilogram dry air, so we have to divide these values with 1000, okay, to convert the unit. All right, so that is for specific humidity. And then we have the enthalpy ruler there. Okay, so values from 20, 30, 40, 50 up until 120. So that is the enthalpy ruler. And then when we move into the graph, there are some inclined lines, garisan condong kat dalam graph tu. Okay, there are a few inclined lines here. So the first one we see is for the wet bulb temperature. That is the dotted line. Okay, try to look for the value 25 degree wet bulb temperature. So you can see that there is a dotted line there. So those dotted lines are for wet bulb temperature. And then we have the specific volume, okay, inclined line. Okay, try to look for the value 0.82. Okay, so 0.82, 0.83, 0.84, those are the lines for a specific volume. Okay, so and then we have the curve line. Okay, the curve line, okay, that is for relative humidity, 10%, 20%, 30%, up until 100%. Okay, and then we have the dew point temperature, the last curve line on the graph, okay, next to the enthalpy ruler. Okay, the final curve line, that is for the dew point temperature. Okay, 5, 10, 15, 20, 25, up until 30. Okay, so each property is represented at a certain location, okay, in the psychrometric chart. Okay, so when we want to use the psychrometric chart, we have to have at least, okay, two of the properties, so we can plot. Okay, so we have to have two properties we can plot, and the remaining 5 properties we can read, okay, from the chart. Okay, and another reminder is that the psychrometric chart is only for pressure of 1 atm. Okay, 1 atm, only then can we use the psychrometric chart. 1 atm is equal to 101.325 kilopascal. Okay, higher than 1 atm, lower than 1 atm, we cannot use the psychrometric chart. So that is the disadvantage for psychrometric chart. Okay, we cannot simply use it. We have to look at the pressure, and the pressure, it must be in 1 atm. Okay, so next we look at the example on how to use the psychrometric chart. So from the question, we have to identify two properties first. So we have here 35 degrees Celsius and 40% relative humidity. So we can plot these two values, and then from the point of where we have plot these two values, we can read the remaining 5 values. Okay, so first we have to plot. So we look for 35 degrees Celsius and we draw the property line. Okay, so we draw the property line for 35 degrees Celsius until it intersects with 40% relative humidity. Okay, until it intersects with 40% relative humidity, and then we label it as state 1. Okay, state 1, and from here we can draw the remaining property lines to read the remaining properties. Okay, so the first property is for omega. So we draw a horizontal line to the y-axis on the right. Okay, straight horizontal line. Okay, and this line must be parallel to the nearest line. Lukis garisan yang selari dengan garisan yang paling rapat dengan dia. Okay, so we have here, if we were to read from the chart, it's 14.2, approximately 14.2. Okay, so but remember that we have to divide it by 1000. Okay, divide it by 1000 to convert the unit from grams to kilogram. Okay, so 14.2 divided by 100, we get 0.0142. Okay, so that is for specific humidity. For enthalpy, draw a straight parallel line, okay, to the enthalpy ruler. Okay, so we draw a straight parallel line, and then until it intersects with the enthalpy ruler. So we try to read as precise as possible. So here we can get 72 kilojoules per kg. Okay, and for wet bulb temperature, if we look closely, state 1 now is on top of a dotted line. Okay, is on top of a dotted line, and this dotted line is corresponding to 24 degrees Celsius. Because why? Because the dotted line above it is 24. So this one is above it is 25. So this one is below 25, so 24. Okay, if it is in between, let's say if it is in between 24 and 25, try to read as precise as possible. Okay, draw the line first and then try to read as precise as possible. Okay, so for dew point temperature, we will draw a horizontal line, okay, to the left, and this one will read 19.4, okay, 19.4. And for the dew point temperature, be careful with uh, the range, okay, because not all range has equal spacing. Okay, if we look at between 10 and 15, there is maybe 6 spacing. Okay, if we look between 15 and 20, there are 8 spacings. So the spacing between these values for temperature is not the same, so we have to divide it equally, and when we read it, we have to read it as precise as possible. Okay, and for specific volume, we draw the inclined line with respect to the specific volume. So we draw a straight parallel line, okay, to the nearest line, and we try to read as precise as possible. Okay, so we have above it 0.9, below it 0.89. So it's in between 0.89 and 0.9. So we try to read as precise as possible. Okay, but first make sure you draw the straight parallel line with respect to the property. Okay, so this is a simple example on how to use the psychrometric chart. Please try the question in the original notes. Okay, I believe that the answers are already there. There might be some difference. Okay, but try to read and try to do the psychrometric chart question. Okay. So for this video lesson, we have come to the end. Okay, we will continue with the next subtopic in the next video lesson. So thank you and have a good day.